Okay, so we're going to graph a few more rational functions on this video. The previous video was a shortcut on how to find horizontal asymptotes, so we'll take advantage of that to make this process go a little bit faster. But I think graphing rational functions, a common question is from students, they know how to find the asymptotes, they know how to find the intercepts, and it's just overwhelming to try to put all that together and get the graph. So I think more practice is going to help. So that's why we're going to go through these 3 examples. And I already have another video planned after this one for some more complicated rational functions. Okay, so let's start with, if I'm graphing a rational function, I like to start with the intercepts. In particular, I always start with the X-intercepts because that's when you're setting y equal to 0. And when you set a fraction equal to 0, it's the numerator that's going to make it equal to 0. This would just multiply over and become 0. So 0 equals 3x squared. And that's going to give me x equals 0. Okay, we were talking about with polynomials, we've been talking about x-intercepts that either bounce off the x-axis or pass through. This 0 came from an x to an even power, and so that is going to be a bouncing x-intercept. So when it hits the x-axis at 0, it's either going to bounce off below or bounce off above. It's one of those two. Okay, since my x-intercept was 0, that's my one and only y-intercept, so I wouldn't bother with that. My vertical asymptote, which is where f of x is undefined, as long as, okay, there's no common factors in the top and the bottom, which there isn't here. My fraction's undefined when x minus 4 squared is equal to 0, which gives me x equals 4. And for vertical asymptotes, the classification is opposite or same. In this case, since my 4 comes from a factor that's to an even power, this is what we would classify it as same. And what that means, so we might as well add x equals 4 here. So that's a vertical line. Let's just say it's right here. What same means is that if I find out, let's say on the left side, that my function approaches the asymptote going to positive infinity, on the other side, it will do the same thing. Or vice versa. If I find that it's going to go down to negative infinity on the left side, then it would do the same thing on the right side. That's what we mean by same, but we haven't figured that out yet. Okay, next would be our horizontal asymptote. And for our horizontal asymptote, I'll put this in right here. We want to think about what happens to our function as x goes to plus or minus infinity. I always start with positive infinity. And my function, what you would want to do in this situation is expand out the denominator, FOIL that out. X minus 4 quantity squared would give you x squared minus 8x plus 16. Both the numerator and denominator are going to get really big as x goes to infinity. But what we've discussed on the previous video is we could just focus on the highest powered terms in the top and the bottom. So if I just looked at those, and these are the same powers, if I have 3x squared over x squareds cancel, I just get 3. So my horizontal asymptote is y equals 3. Slide this back up here. So that would be a dashed line like this. Okay, now it's time to graph our function here. So remember that on our vertical asymptote, there is graph on either side of our vertical asymptote. So if we started on the right side, and remember also that your functions always approach the vertical asymptote. So one option is the graph would go up here, and then it also has to approach the horizontal asymptote, so it could curve down like this. Or if it didn't go up, maybe it goes down on this side. Now, the trouble with that is if it went down here and it has to approach this horizontal asymptote, what would have to happen right here? This would be an x-intercept. And we found our one and only x-intercept at 0. So I know, even without testing anything, I know it cannot do this because I would have to cross the x-axis. So I know that my only other alternative would be this. It has to be up at the top. Okay, if you don't get that, you could always plug in a number, something bigger than 4. If I plug in, for example, 5 for x, that's going to be a big number on, well, what is that going to be? 3 times 5 squared. 3 times 25 is 75. 5 minus 4 is 1. 75 over 1. So this is definitely not drawn to scale, but a point on this graph is 575. I don't really care about the scale. I just want you to know that it's up here. Okay, we classified this vertical asymptote as same. So if we're pretty sure now on the right side the graph goes up, that means on the left side the graph goes up on this vertical asymptote. Now we have this intercept of 0 that the graph has to get to. So the only option is this function is going to have to cross our horizontal asymptote. Something we talked about in a previous video. That's okay. In fact, I can expand on this a little bit more. If your function needs to cross a horizontal asymptote to get where it needs to be, then it can. It's a bouncing intercept, so it's going to have to bounce off and then start to approach my horizontal asymptote of y equals 3 as x goes to negative infinity. A little bit more on crossing the horizontal asymptote. To really convince you that it does cross right here, I could actually locate this point. Because notice this point right here, I don't know the x value, but I do know the y value would have to be 3. So if I want to find out where this crosses, what I could do is set my function, set y equal to 3. I'm going to do this down below here. So I'm going to say crosses horizontal asymptote of y equals 3. I would just set 3 equal to my function. Now I had x minus 4 squared, but I'm going to use the factored out version, x squared minus 8x plus 16. If I cross multiply, if I multiply this 3 by everybody, so 3x squared minus 24x plus 48 would equal 3x squared. Notice the 3x squareds cancel out, and that leaves me with negative 24x plus 48 equals 0. If I move the 24x over to the other side, divide by 24, we can get that x is equal to 2. Which, if you go back to your graph, that seems very reasonable. That this point where it crosses, this is 4, this is 0, it actually crosses here. My question mark almost looks like a 2. That crosses at the point 2, 3. Sometimes books will ask you to find where your graph crosses the horizontal asymptote, and that's how you do it. You just set your whatever your horizontal asymptote is equal to your function and solve for x. Now, if you don't get a solution here, that means your graph doesn't cross the horizontal asymptote, and your graph should reflect that as well. Okay, let's move on to another one. F of x equals 2x over x squared minus 16. One thing I guess I didn't check on the previous one, but maybe a first thing to do is to check to see if it's an odd or an even function. If you've been practicing that, you might be better at kind of spotting an odd function and an even function. I can see here, so I'm going to put odd or even. The previous one we just did was not odd or even, so it didn't really matter. But if I replace my x's with negative x's, two times negative x is really negative 2x, and that's just going to stay the same. And I can see that this is just the negative of my original function at the top, and that makes this an odd function. So it's going to have symmetry about the origin. Okay. So then we'll pick up with our intercepts. So our x-intercept, we're setting 0 equal to our fraction, which is really just going to come down to the numerator. And that's going to be x equals 0. Notice my 0 comes from an odd power of x. So this one would be considered a through x-intercept. My vertical asymptotes. F of x is undefined whenever x squared minus 16 is equal to 0, that's the denominator, which I'm going to factor because I want you to see that there's two vertical asymptotes, -4 and +4. And in reality, those vertical asymptotes come from factors that are to an odd power. Odd power we associate with opposite in terms of vertical asymptotes. Opposite means if on one side it goes up, the other side it goes down, or vice versa. Okay, in fact, let's add those to our graph. We have an x-intercept of 0, vertical asymptote of x equals 4, and -4. And by the way, this is just a subtle suggestion for people who if you have trouble, you can get all the information, but you have trouble graphing it. Notice what I'm doing is I'm adding to my graph as I learn things, right? Because if you wait till the end, it is kind of too much information, right? It's just a lot of information. In fact, I'm going to put opposite up here on these just to remind myself that these vertical asymptotes are opposite. And this one's a through. You can even put like a little T for through if you want, knowing that the graph's going to pass through the x-axis there, one way or the other. All right, last thing, horizontal asymptote. We're thinking about what happens as x goes to plus or minus infinity. I'll go ahead and put plus or minus infinity. 2x over x squared minus 16. And we know now that even though both the top and the bottom would be getting really, really big, we focus on the biggest power of x in the top and the bottom. So this would be approximately equal to the limit as x approaches plus or minus infinity of 2x over x squared, right? Ignore the 16, which is really 2 over x if you reduce that. And what would happen if you plugged in plus or minus infinity into 2 over infinity or 2 over negative infinity? You can hopefully see that that would get really, really small. My horizontal asymptote is going to be y equals 0. We also talked about on the previous video that if your biggest power of x is in the denominator, then you should expect your horizontal asymptote to be 0. So back to my graph, that means the x-axis is dashed. Okay, and now we have to graph. There's no real great place to start here. On the right side of this vertical asymptote, my options are this or this. And I really don't have any way to know for this particular one. So here I really do have to pick a point. If I plug in something bigger than 4, like 5, maybe I can squeeze this in right here. What is f of 5? That's going to be 10. 5 squared is 25 minus 16 is 9, 10/9. So that's something positive. 5, 10/9. So I can tell them my graph is, at least to the right of the vertical asymptote, looks like this. Since we know this is an opposite vertical asymptote, and we know on the right side the graph is going up to positive infinity, on the other side it's going to do the opposite. So it should be coming down here. Now let's go from right to left. We know this is a through intercept, so it's going to come right through, crossing my horizontal asymptote. That's fine. In fact, we know it crosses at 0. And the only option that it's got to keep going up, right? Because it can't come back down and have another x-intercept. So it's going to keep going up like this. This is an opposite vertical asymptote. So this side goes up, the other side goes down. We'll approach 0 in this direction. And notice it has that odd symmetry to it in that if you just looked at the right half and reflected it around the y-axis and then reflected that around the x-axis, this would go over here and then get reflected here, and this would reflect down here and go up. Hopefully you can see that that's, and you know, what's another point on this graph? 5 10/9 was on here, so that means -5, -10/9 would be on this graph as well. Okay, one more for this video. F of x equals x squared minus 4x minus 12 over x minus 1. And for this one, I want you to remember that if you have a fraction where the degree, so I'm going to say, if the degree of the top is greater than the bottom by 1 power, because that's very common. These types of graphs are very common. By 1 power, then what we should expect is to get a slant asymptote. You will have a slant asymptote, not a horizontal one. It's one that's on a line. Okay, and we discussed that on the previous video, why that's true. So we're not going to bother finding a horizontal asymptote. We're going to go straight into finding the slant asymptote. But I still recommend sticking with the same steps here. I don't think that would be odd, or even if I plug in negative x. So we'll go straight to, let's factor this first to find our x-intercepts, because we'd be setting this equal to 0. The top factors into x minus 6, x plus 2. And nothing cancels here. So my x-intercepts, if I set this equal to 0, it's only going to be the numerator that makes this 0, because I could multiply that over. I'm going to get x equals 6 or negative 2. Both of those coming from odd powers. So these will both be through x-intercepts. Since neither of those was 0, I might as well find a y-intercept, because that's a really easy point to find. You're just plugging in 0 for all of your x's. And if x is 0, that's 0, that's 0, that's 0, I'm just going to get negative 12 over negative 1. I'm going to get 0, 12. My vertical asymptote, f of x is undefined when the bottom is 0. So that's going to happen when x minus 1 equals 0, which gives me x equals 1. And that's coming from, I mean, I could put parentheses around there and argue that that's coming from a factor to the first power, which is an odd power. So this will be opposite behavior. And then, yeah, getting to the slant asymptote now that we know it's going to be the slant asymptote, I'm not going to just jump straight into taking the limit as x goes to infinity. What I first have to do, remember, is to rewrite this fraction with long division. Rewrite f of x using long division to find the slant asymptote. Just abbreviate it. So we want to divide. In this one, you could do synthetic division if you know it. I'm going to go ahead and do regular long division. So if I put an x there, this times this will generate an x squared, which is what I want. But I'll also get a minus x. Subtract. X squared minus x squared cancels. Negative 4x minus negative x is really going to be adding, so that's minus 3x. Now I want to cancel this out, so I'm going to just put a minus 3 there. Minus 3x plus 3. Negative 3x minus negative cancels. Negative 12 minus 3 gives me a remainder of negative 15, which I can write as negative 15 over x minus 1. So this is the same as my original function, just written in a different form. And now I can see that if I were to consider what happens as x goes to plus or minus infinity for x minus 3, I'm going to just move the minus down, minus 15 over x minus 1. I can see that in either case, 15 over infinity minus 1 or negative infinity minus 1 is going to get really small. Now, if x goes to positive infinity, infinity minus 3 gives me positive infinity. But if x went to negative infinity minus 3 would give me negative infinity. So I know my limit's going to be plus or minus infinity, but the important thing is my graph approaches plus or minus infinity, along the line y equals x minus 3. So now, okay, I didn't add everything that I recommended before, but we can just throw this stuff in here. So I have, let's see, I'm going to start with my vertical asymptote is x equals 1. My x-intercepts are 6 and negative 2. Let's call this -2. Let's call 6 like out here somewhere. Y-intercept is 0, 12, so it's way up here somewhere. And my slant asymptote is y equals x minus 3. That's a line that has a y-intercept of -3, so maybe down here, and a slope of 1, or you could say that there's a, bring it back in here. Y equals x minus 3 has a y-intercept of -3, an x-intercept of +3, -3, let's say this is +3. So my slant asymptote would look like this. Y equals x minus 3. And so what we know, then we also know that these intercepts were both through intercepts. So I kind of see what would, and it has to approach this asymptote in the end, in both ends of the graph. So I kind of seeing here that it's, if this is a through intercept, the only way it could approach this intercept is if it went something like this and approached 1 like this, and it's going to approach this this slant asymptote in that direction. Remember that this was an opposite vertical asymptote, so that I know that if it went up on the left side, it's coming on the opposite side. It's going to be going down, going through my x-intercept of 6 and approaching this slant asymptote to the right. All right. So those are kind of, I did go through 3 different functions in the sense that one had a horizontal asymptote of 3, the next one was 0, and this one has a slant asymptote. And those are kind of the 3 ideas in terms of horizontal asymptotes. So I'm going to put one more video up after this with a few more complicated rational functions, but hopefully this helps and you're getting better at graphing these.